Hello everybody, welcome to another stream. How we're doing? So last stream we got the AMD single pass down sampler ported over to the HTC compiler and this code base as well. So now we can basically, whenever we want to build a special down sampler, we can literally just include a header file, pre-declare a couple of there you go. Pre-declare some macro and the load and store functions for the downsampler and the reduce function. Include the header and boom, we got ourselves a special occlusion buffer downsampler. So we can then call that and all that good stuff. So that's pretty great. I forgot we probably need to undef at the end of this. Because at the start we check if it's defined. And yeah, so cool. Now, hey Alex, welcome sir, how you doing? Let's take a walk, yeah. Well, about that walk. Oh my days. So, sad news today. So I set up my treadmill yesterday and I was like, this is amazing. Best thing ever. And then today, well, basically I was like, well, you know, I read somewhere that you need to lubricate it with some of the silicon oil or whatever it's called. So I got some of that and I put it on it. Well, I followed the instructions basically. And then what happened is when I trod on it, it started like sticking. I was like, damn it. What's going on here? So now, basically, I don't even know what to do with it. I tried taking the oil off. I tried doing the tightening stuff that's suggested in the manual, and it still sticks. So I've just sort of sent a message to the people to try and see what I can do about it. Hopefully trying to get some form of replacement if it can't be solved. But yeah, it's a right pain in the butt. So that's currently on the back burner, which is a shame. So I'm just standing right now, just trying to make sure I don't keep too mobile. Sorry, too still, should I say, or keep a little bit mobile so my knees don't get too strained. But yeah, how are you doing, Alex? How's things been? So this is some other graphical glitch we're going to fix next stream. But we got the occlusion buffer working, which is super great. Which means we get this. It's basically a depth buffer that gets rendered before the scene gets rendered out, but it's rendered at half resolution. And if we take a look, it also downsamples. So we can look at these MIPS. But the problem is my texture viewer doesn't, adjust properly. So we've got to go ahead and fix this. And I think it's a very easy fix. I was just super dumb about it the other day and was just confused. But I know why it broke, because it's used to work where it would stay. It would even zoom in and everything. So let's fix this, and then we'll go over this sort of like downsampler and see it in the profiler and everything and see how well it performs. And then we'll move on and do some other things as well. So if we go to the graphics side of things, there is a where we kick off the downsample. Here. We've got a little to-do list. Fix texture viewer MIP changing code. So this is in the GPU library because it was just easier to put it in there. I got second thoughts about putting it in a GPU abstraction, but anyway, there we go. It's in there at the moment. So texture viewer, and in here, something to do with like MIP something. Let's do that. Right, yeah, here we go. So if the MIP changes when we change it in the drop-down menu, right, that little combo box. I think all we need to do is just change the scale. I think that's all we need to do. No offset needs to be changed, and the reason is because the rendering code changed when we render the image. What happened? So now it's like center aligned, but it used to be like lower left aligned or something like this. So that's why I used to have to sort of like offset it, because it used to be aligned to the lower left, and the resolution of the image used to, oh, it was something like that. So I think we just don't have to change the offset, and we only have to just modify the scale of the image. So we'll just try that out quickly. Good, thank you, Ozone, from your code base. Awesome. Awesome stuff. What you working on at the moment? Are you working on the Alexa, isn't it? Or the little parser? What is that parser for by any chance? What are you parsing? Alright, that did not work. No. I think this calls for a bunch of print statements. Right, so when we render, we're getting the half dims of the texture at that MIP level. Like, why are we even doing any of that? And then we get in the center of what? Right, of the right split area. Okay, so I'm interested to see whether or not this has changed then. So if we print out okay, maybe it's a little bit more complicated than I thought. So we just do view offset X, view offset Y. Let's see what happens there. Yeah, work on interpreter. Awesome. Started with the HC compiler to keep the spy the parts of finally do the code stuff and jump on the code base. Thank you. That's cool. Yeah, appreciate your support. Yeah, the game without engine code base is definitely much better because it's my sort of latest project. So I've learned, yeah, I tested some things out on the HTC project and learned from that. It's my latest work. Yeah, what is it? Is the interpreter a custom language, and are you doing it to sort of learn compilers and stuff like that? Is that the idea? Right, so the view offset is not changing. Oh, I know what's going on. Right. Or do I? Yeah. So the center isn't changing, right? This is the full resolution of the image, right? And then when you change the MIP, it's just sort of shrinking it, right? Which makes sense. I don't know why that goes there like that, though. Oh, these ones are not initialized. It's something like that. Right, it's got 11 MIPs. But to get down to a 1 by 1, it goes up to, yeah, when you go past the 1 by 1, the rest of them are sort of initialized in a very weird way, right? Okay, so right. So this shrinks the texture dims. Yeah, I don't know why I need to, so maybe it will maybe let's float cast this. So let's not change the texture dims. Let's see how that works. Okay. Right. Okay, so this is where we will need an offset then. Right, so let's take that code there. Let's undo all this, because yeah, there's this offset code that I removed. Okay, so I'll put that back. So we don't change it based on the MIP, and then we tell it to offset. And you change the scale. See what happens there. Oh crap. Right, here we go, so. It's better, I think. It needs to offset by more or something. So, I think we need to offset by, you take the resolution and you add. Right, let's not change anything. Let's say if the value, the MIP level changed, just do nothing. And we'll see how it behaves by just keeping it at the same texture resolution and not even changing anything to the scale or the zoom. Right, so as we're seeing, it's just shrinking down like this. So if we offset it, so right, so if you take that, so you need to offset it by half of this resolution. Okay, yeah. So at that MIP level, so you get the new MIP level. What's the way of saying it? You probably need to get a scale difference. Divided by old scale? Let's just try something like that. See what happens. So we'll still change the scale, but we'll also we'll scale the offset. Something like that. But then if it's 0, bit of a problem. That's not going to work, is it? So So you probably need to scale that onto the dimensions of the overall texture. So what's this offset in? Spline point coordinates. So if we go and say like offset is equal to the texture dimensions. I've already got the resource up there actually, haven't I? So be resource texture dims.xy. And then I want to make sure that it's scaled by scale difference or whatever, I don't know, something like that. And that will get us, hopefully, offset.xy. The right offset when we change the zoom. Or change the MIP. And it tries to zoom in and offset. Alright, it's way too far. But it's interesting. Right, so it's way too much. Oh, so that'd have been 2 times or whatever. So maybe it's because I multiplied rather than divided. All you want is probably a divide of that. I think. Because you'll get the number 2 times. You get 2 times zoom. So you need to offset. You need to divide it. And you want to offset by the half, I think. If math serves me right. Oh, that worked. That one didn't work. No. Right, so we're calculating that offset wrong, but the idea stays. So yeah, I think we want to take that MIP. So you want to do like a shift right, or bit shift right, U32 times 2, and then you like max 1 it, just in case you go too far. Max, well, not really, because it'd be 0. That's cool. Anyway, so shift right by how many based on the MIP level? So that is the new MIP. You're talking about the old MIP? Probably. Yeah, the original MIP. So what's the old MIP? Old MIP. Good. Let's try that one out. What's this one complaining about now? Now it needs to be shift right S for the scalar's argument. Q. Oh, okay, what have I got? I got a Corsair RGB rainbow vomit keyboard, whatever it is. It's alright, does the job. Corsair. K70. Oh, this one. It's pretty alright. It's got the blues, I think, or the I think I got the blues. No, I got the reds. Yeah, I got the reds. I don't really know much of the difference. My first mechanical keyboard. Well, I probably had one when I was younger, maybe, but first one that I bought recently. It's got a little wrist support, and then I've got an extra little wrist support on it, so got extra elevation because it's a bit tall. But yeah, feels good. Much better than any other keyboard I've been using. I'm working on something like a mixture of Desmos, right? Nice. And Jupyter notebooks. Ah, okay. I've not heard of Jupyter notebooks. Is it like another maths thing? Right, so you can note. Oh, so you can put notes down and put like maths in there. Interesting. Cool. Nice. Got like a little project you're making. That's great. I do like project-based development. Hey, Captain Chica, how you doing, sir? I do like project-based development. You know, have an idea in mind on to build something. Because it's like it's something realistic rather than just doodling around doing something that's just made up. Even if you're doing something that's kind of pointless, like building a virtual machine with an interpreter. I did that where I built one. It was a made up. Here's what I mean by pointless. It was a made up instruction set for. It was a mixture between Intel and ARM assembly because I did it to learn assembly. So I was like, how can I study ARM and Intel at the same time while I build my own CPU architecture, just fake it all, and basically build a simulator for it. And yeah, it was a lot of fun. I learned a lot. Wrote my own assembler, disassembler, and ran a couple of basic demos in it. And then that was it. Called it a day. Put it away and never touched it again. But yeah, project-based development. Good idea. But yeah, see, you're building an interpreter for actually interpreting like math stuff by the looks of it, right? And running that. Is that what you're saying? No, I didn't build the chip, of course not. Not smart enough to do that, and that's not really not the idea. Not the idea of the project. The project was to learn about assembly, it wasn't to learn about like building a CPU. Yeah, it was good. Done what it was set out to do. So I think that's right. Give that a launch. I'll press F8. It's running a 4K screenshot. Single threaded on CPU. Okay, it's done. That's terribly slow. Right. Damn it. Right, so let's figure out this maths. If you're going from MIP1 to MIP2, and you need to offset the image, you need to offset it. For crying out loud, it's over again. Where's my dad? Yeah, let me just answer my dad. I'll be right back. Alright, welcome back everyone. Yes, although defining functions, variables can control flow, loops, if else. Oh, okay, cool. This seems like a proper full-on language then, that's great. Why build ISA somewhat if it's not chip? Well, I did go over that reason. I said I wanted to learn assembly, so I thought why not sort of, implement the tooling around a custom assembler, which is for a custom ISA, right? And that was the reason. You know. Because if I did it for like a modern day CPU, it would have been like more complicated than it would have needed to be, Right, so let's do the maths. So basically, we need to offset the image by half it. Right, so if I didn't run this at all and just looked at it. Again, we see that when we take, right, we change the MIP level, it just shrinks it down by half. So we already do the zoom in correctly. It's just we need to offset by half of, well, it's the half of the new MIP level, isn't it? Not the old MIP level. But that's only if we change by 1. Or we offset by a quarter of the one that we came before it, isn't it? We go down, but if we go by 2, we need to offset by the half of the original resolution that it came from, plus half of this. So is that how it works for this one? Nope. All right. Right, so maybe it's a little bit. Right, so maybe we do need that division thing. Right, so that needs to go there. So that is literally, it was just half the resolution. It should be half of the new resolution. Whereas if we did 2, it would be 2.5. Yeah, so maybe if you take the base resolution, you will need to offset by 1/4. And then if you go to this one, what is that you need to offset by? So as 1/4, it would be probably another half of the 1/4, so 0.125 maybe. So, right, so if we try and get those numbers instead, so it's the original MIP. So if we've dropped down from 0 to 2, so I guess you can get the MIP diff, which we've got there. That's going towards the new MIP from the old MIP. Right. So that'll get you like a negative. Right, interesting. So maybe you can get some kind of, do something with the offset as well. So yeah, if it's positive or negative, you do the divider. Okay. So I think we can get this new kind of offset thing. All right, this will do it. All right, so if it's right, let's do the negative one because that's the one I was already kind of thinking about. So you're like a -2. You also need to make that positive, that MIP. So you're absolutely right. And the idea is you want to, so you want to get 1/4 if it's 1. So the difference is 1, you want it to be 1/4. If the difference is 2, you want it to probably be 0.125, I think. So you add 1, that'll get you 2, right? Do 1 divided by 2, and then you multiply it by 0.5, because you need half of that, and I think that's what you want. Now, that's obviously division. Here you want it to multiply. And I think we can work with that. Let's just put that one there. Oh, we might do a divide actually. Yeah. I don't know. We'll see. See if that works. So we'll see if it works by scaling down, and then we'll try scaling up and see if that happens to work. Righty-o, so but that didn't offset anything. Oh, did I and 0 it again? Yeah, I did. Whoopsie. Well, that failed. Whoopsie. So the MIP diff. Weird. So you move by 1. 1, and you add 1. 0.5. Did we offset by way too much? Oh, wait, the wrong way around. I think I was going to get a positive number, actually, in the way I was... Yeah, so did it divide? So it just... It went the wrong way, I think. Silly me. Right, that's a bit better. Not quite what we wanted. Right. So it kind of like was not offset by enough. What sort of number was we getting with that? Maths. So we'll be able to see that number now. It's got to be a quarter. Well, maybe it had to just be a half. Shoot, we lost that one. But yeah, it did offset it such that we got here. But it needs to be like there. So I think actually maybe the quarter wasn't... maybe it just needs to be... Maybe it just needs to be the half. Try that out. Right, there we go, that worked. Then the 2 one doesn't work. Crying out loud. So that one didn't offset it enough. So we don't do any shifting. Is that right? Right. So I can try and center the image instead of doing this steady offset thing. Yeah, let's do it that way. This is just a bit weird. So let's keep it so we just scale it instead. Right, we can get that maths fine. But when we render it, the problem is that to view it in the texture viewer, we copy it to a different texture, which I think is, if we look at the texture viewer, copy texture, I think, what's it called, the copy texture? Oh, it's reinitialized right to the texture dims. But if we get it to respect the MIP level, okay. Right, yeah, this is the code that ends up changing. So when we view a texture in the texture viewer, we can't just view the one that we're trying to view. We actually have, because we can view it at a certain point in history. So what we do is we insert this dispatch copy, and right at the point in time where we want to view it, we take it and we put it into another texture. Now that because we have different size textures, it originally used to be one sort of like 4K image, and we didn't use to support anything bigger than that. But then that kind of had its own problems, so I switched it to have a texture got reinitialized. And yeah, this is why that MIP level zooming thing broke, because I changed this code. You know, you try to fix something, you break something else. It's the way development works. So what I'm not doing here is, so I'm copying it at the correct resolution for the MIP level, but I'm not making it the right size. So therefore it's gonna have a weird offset. So if we do it this way, we're gonna have to try and do silly maths to try and get the offset right in the UI, right? Instead, we can just size the texture to be correct, and then it'll be we can just center align it like we do with the base resolution, and then that should do it. Oh my days. Ah, beautiful. This is the right way to solve it. So what am I doing? Oh, I need a 3D coordinator, do I? Right. Hang on a minute. Cool. Wait, I just gotta do a dims.xy and yeah, that'll work. Okay. This is gonna do it. Let's look at some things. There was something in the collision texture. Did the offset change still? No. Right, let's disable this zoom code. Oh, wait a minute. Yeah. So the problem is this code here got changed where it's not obeying. Okay. Nearly there. I need this code. So this code, when it renders the texture in the scene, it's centered, but the dimensions here is wrong, or the half dims is wrong. So I need the dims of the texture. And I take that, cast it into a float vector, and then do the make it half dims, and then do the drawing code. This should be it. No. Something else is a bit sketchy. So I'm probably using the resource dims somewhere else as well now. So hang on a minute. Just look around for this. Right, so it's not even doing the resize here because I didn't pass in the dims. So it didn't even try and reinitialize the texture because it's like, well, the copy texture dims were perfectly fine. And yeah, so I think that is the next problem. And that's working. Finally, this is what we want. Good. Now, if we go too far, it's going to... Oh yeah, that's good. It goes down to 1 pixel, just what we wanted. Very nice. Awesome. So as we can tell with this radio, so we bring up the profiler. Let's get to a bit of a better scene, and we can see what's going on with this occlusion buffer. So again, we've got these glitches where things reshuffle in their Z. Fixing that hopefully next stream if things go to plan. We bring up the profile of F4. Here it is. We do this sort of depth pre-pass kind of thing by rendering the whole scene at half resolution. Still some more optimizations we can make. We've still got to actually make a whole bunch of instances anyway, so don't take these numbers for certain. That is coming. We'll really study these numbers properly later. But as you can tell, it is overall more than half the cost of rendering the actual models, and we haven't even got the occlusion testing or anything like that in. So just rendering this scene at half resolution and only rendering what else it's already half the speed or whatever, right? So or it's more than half as, yes, 2 times as quick, right, or more. But the tile binning is still as expensive. We're going to improve that later on too, when we have a more complex scene and can test numbers. So this does a depth pre-pass at half resolution by sorting all of these into screen tiles, and then this is the ray tracer here. So if I just zoom in, we'll see there's the ellipsoid occlusion ray tracer. It just renders out the depth to this occlusion texture MIP 0. There's the shader here. And then after that, we do this here, which will downsample and do a max operation between a 2x2 set of pixels to make a pixel. So this means that whenever I want to check if something is fully occluded, we get the rectangle of the object. Say if it's behind this thing here, we get the rectangle of the object, and we at the MIP level where the object is 2x2 set of pixels, sample those 4 pixels, take the max of that, and I think it's the max, and then test that depth with our object, the closest part of that object, and if it is behind that, then it means that it's definitely occluded and we cannot render that object. So for a more complex scene, this is very much going to pay off a lot. For a simple scene, it's not going to pay off. So that's what we're going to work on today. Where's the downsample cost, you ask? Is here. To downsample that image, it was 0.02 ms. You know, it's a half resolution of a 4K screen, so it's actually kind of really quick. There's lots of barriers in here, so that's why we're getting these holes in between things. If we remove the barriers with Alt V, it really squishes down on overlaps. If we pause it and take a look, there's a lot less barrier weighting because it inserts barriers aggressively to kind of make it so there's no overlapping going on. But there we go. All right, so what's next on the to-do list? So we've sorted out that texture view thing so we can actually view the MIP levels without being all crazy. Yeah, so there's this, with this downsample code, this next one is a little piece of work. With this downsample code, we make an assumption, and that is that, right, so the biggest pain in the butt with, or one of a pain with the current APIs for graphics is you cannot just have a texture of a bunch of MIP levels and write to any MIP level. You can sample from any MIP level, but you cannot, I think it's sample, but you cannot load and you cannot store. Let me just double check that load one. It's so confusing, all these things. Yeah, you can only fetch a texel from a sample texture, that's it. But not from a storage texture you cannot load or you cannot store to a particular MIP level for some reason, even though it's probably just some memory addressing thing. I don't know why. There's probably some GPU that doesn't support it, so we can't have good things. So the way you get around that problem is you basically create a texture, right? And this is given a certain index of x, right? Then you create a x plus 1, a texture view, which points to MIP 1. And this will point to MIP whatever to 10 if you have 10 MIPs, right? But because whenever you store to this texture, it always stores to MIP 0. Whenever you load, it loads from MIP 0. It never touches the other MIPs. So then you create another texture view, bx plus 2, or the ID of it, so it's be ID plus 1, ID plus 2, and that points to MIP 2, right? So we need a little function to help us create all of these texture views when we have this MIP chain thing, because when we do this downsample and we store all of the texture, or realistically we don't have to have an array of textures in here because it's just a bit of maths, right? We know it's an ID plus the MIP. So really we need to store the base. Yeah, one of them in there. Okay, we can clean this code up a bit. Yeah, see here we just get the resource ID and we say plus MIP. So when we initialize those, occlusion texture, see here, I go over them and this one here just initializes them, but it doesn't sort of like set them up properly because not all of them need to exist, because this occlusion texture can change resolution. It gets reinitialized when we sort of move when we resize the screen. So I really got to be careful. Because yeah, let's just make the abstraction that works with this one, and if it needs to be changed for whatever, because I need another one of these, we can just change it then. I just want to make it such that it is in a function, because it's going to be a standard way of working in the future when it comes to this downsample code. So we should probably have a GPU texture initialize MIP views. So you'll pass in the occlusion texture ID, so that's the base ID. You then will pass in all of the MIP levels. So maybe you just say, so here's the thing, right? We have said we only have one MIP here. One of these is array layers, one of these is MIPs. So maybe we can change this code to work with that, and then it doesn't have to worry about, yeah, okay, it will work. Okay, so GPU texture init MIP views. So we'll take in a resource ID for the texture ID, and then do I need the number of MIPs? Not really, because that is already provided as part of the so we can just do something like MIPs count equal GP MIPs texture MIPs count, something like that. And then you simply just, you probably want to assert and say, no. Wait. No, you need a capacity. What's the maximum number? So if the MIPS cap is equal to 0, then you're just saying work it out automatically for me, and it would just be the current count. And then you still want to initialize the capacity's worth. Yeah. And you start from 1. I guess you want the name, but the name could also just come from whatever. It's kind of an internal function, we'll sort out later. Resource texture. MIP levels. That's what it's called. Cool. So this will be the name. So resource name. Now I'm going to be careful here. So base MIP level, number of MIP levels. So the base I think that's right. Where's the reinit static stuff? We did it for... Here we go, so when we reinitialize it. Alright, let's take this line. Probably it's very similar to this. So it's the base MIP level. And it's the minimum between that and the number... The latest initialized one, so it's MIPS count. And then we only want to have a view of one MIP. Right, I think that's it. So that just initializes them, great. Then we need another one of these which reinitializes them, which is a bit different. So that's the capacity, where it just instantiates all of them. Very nice, so let's find the header file and the implementation. Oh, these are static though, isn't it? For crying out loud. Texture MIP views, init, static. Alright, let's put a better name there. Is this called debug name? Is, isn't it? Okay. Get that music back. So this is just texture ID. Very nice. So we'll do another one of these, which is the reinit as well in a second, actually. Let's go to the header file, chuck that in there like so. Could do with a bit of documentation, but there we go. Right, so the reinitialize, we've got to find that code. Right, this is MIP use init static, beautiful. So re-init okay, so we reinitialize those texture views. So we reinstantiate the occlusion texture as a whole because we resize the screen. Now the texture views that come after that one, these have to be see, I think we just call GPU texture MIP. Oh my days, texture MIP views reinit static GGFX occlusion texture. And then I guess it's using the capacity because it wants to go over all of them. Yeah, so you need the capacity again. Gotcha. So we'll take this with us. We'll find where this is done. Plop that in there. So if your MIPS cap is 0, then I guess... Yes, it's MIPS cap. We get the base. Yeah, we get the MIP res ID, which is just that offsetted by the MIP level. And then it aliases the texture ID at base MIP level min with the resource. Oh crap, I did it wrong, didn't I? I forgot to do the take 1. Off by 1 errors. They're a bugger. Okay, that's the code. Right, so now this is like got a standardized thing within the GPU layer. I'm happy with that code now. Although now we need to adjust the downsample code because I realized we're doing something a bit silly. Boo! Scared ya? No. Hey Quest Wizard, welcome to the stream, sir. How's your day going? You look sounding like you wanted to scare people today. So if we just call this the base texture ID, and that's all we need to pass up now. So base texture ID, and then cool. Now in the shader code, when it comes to the AMD downsample, which we ported over and added our own sort of like generic it was pretty crazy, but yeah, we have a way of declaring loads and stores and a custom reduce function, re-including the header file and getting a completely new shader generated. It's a bit crazy, but it does the job. And it's a pretty optimized shader actually. It's pretty cool. We saw how fast it was. Did it all in 0.02 milliseconds, so it's pretty quick, single pass. It's amazing. We should try it for a bigger resolution and see what happens. We did it at 1500 by 800 because it's half resolution, and ours is kind of like windowed mode 4K resolution. So yeah, maybe we'll need to do a 4K one at some point. It'd be interesting to see how quick it is there. But what are we looking for now? Oh yeah, where we do these loads. It's no longer like a textures thing. It's a base texture ID plus MIP. So this is some example code that I've put in the header file, but let's go to the actual one that we did for the occlusion. Single pass downsampler. Oh, for crying out loud, it's in the shaders. There we go. So this one for the occlusion buffer where it just loads. So base text ID plus MIP. Beautiful. Oh, bugged that one up, didn't I? That's good. Yeah, so one needs to be changed. Right, so let's give that a go. Hopefully it didn't break anything. We just cleaned up the code a bit so it's nicer for future me. Oh no. MIP out of bounds? So that's on the initialize. Strange. Hey, Dale. Thank you so much for the Prime sub, sir. Appreciate you. Appreciate you so much. Welcome to the club. But yeah, I guess I'll take this time to thank all my supporters. Thank you guys for supporting the channel. Appreciate it. All the supporters get access to the code via GitLab, and you can download it and run it on your Linux or Windows machine. You can also pop by the Discord and just say hey and hang about and talk about programming if you fancy. That's also there. Righty-o. So, I broke the code. Very sad. What did I do? So I initialized it with 1. And then I put a capacity in there. So it would have gone over all those. Oh, I thought I put the take 1 in there. Crap, which means I put a take 1 in another piece of code which didn't need a take 1 in it. What did I do? I don't know what I did. I think I put it in some code, then I deleted temporary code which was there, then I deleted it. I copied and pasted the code and I deleted it, didn't I? Silly me. Right, we found the bug. Well, there we go. And we're back up and running, yes. And we check out the occlusion texture. And does it downsampling? Yes, it is. Let's go all the way down to 10. And voila, there's the 1x1 pixel. Cool. You know, we're not really seeing the MIP resolution in here, which is a bit of a shame. So maybe we should just chuck that in there as a bit of a quick nice to have while we are thinking about issues with the texture viewer. So we'll call it the MIP dims. And all we're going to do is take that thing here and we're going to do a max E32 of 1 and this shift right by the number of MIPs. So, you know, this would be better. Better at least. Rightio, so we just take that one there and what did I do? I deleted some code. Right, just made that off the screen and unreadable, but that's okay. I could also shorten it to dims and that might work a bit better. Alright, that's a bit better. Cool, so now when we change that MIP thing in the texture view, it looks pretty nice and... Oh, this is 1x1x1. Ah. That's clearly not what we wanted. Oh. Oh, no, the current MIP level that we're viewing, isn't it? Right, so that's in tab. That'd be in tab. Tab MIP. Whoops, so I was in the total number of MIPs, so obviously just shifted it all the way down to 1 pixel. Because we have a full MIP chain. Cool. Right, so there we go, change it down to half, and there we go. It's pretty nice. 3 pixels by 1x1. Awesome. That's pretty nice to work with. There we go. So let's go ahead and get on with the occlusion buffer stuff. Hopefully we can make good progress on this. So we need to port over the is occluded function. I've got code which I wrote in the past where it does this. So we have an object in the scene, be it a model instance or a ellipsoid. and we need basically get the bounding box around it in 3D space. We translate that to the screen. We've already got a function for that. It's a rough guess. We'll need to be careful about that. We'll want to take the inner bounds of it, I think. We can't take the outer bounds, is that right? Yeah, we've got to get the inner bounds or something like this. No. Yeah, the outer bounds works fine. Yeah, so you get the rough guess of. There's Milton. Right, so here's our wall of ellipsoids. Here's the camera, and we're looking at it from top-down perspective. So let me just try and zoom in a little bit here. Oh, right. So if you have like a model here, right, made up of like 3 ellipsoids, you first of all, before you try and render the model instance, you get the bounding box for it in view space. So it's kind of a rough bounding box. It's not going to be perfect. You then take the screen space bounding box for it, so you project it to the screen. And again, that's not going to be perfect because you've got to pick the sort of best corners based on what quadrant it is in the screen, and that's going to create error as well. So it's not going to be the exact, it's going to be too much. And then you get your bounding box in screen space. And then you take that and find where it is on, at what MIP level will this be, will this fit into a 2x2 set of pixels? Then you sample those 2x2 set of pixels and check the depth at those 2x2 set of pixels and see if it is behind. So the depth here is roughly, you would have rendered something like this. This would be the depth. And then the depth of this will probably be this edge here, right? This front edge. So is this behind this? The answer would be yes. So we will not bother trying to render any of this. So that's the code we're going to write now. So I'm going to go to my previous code and fish out fish that out. So I've got an old folder because we've done this in the past, right? So let's just put in a different text editor. So it's like is occluded. Cool. So we get all of this. So I think there is a better way to write some of this code. There is a sampler you can use and get a max op. It is actually faster, but I've just not bothered using it. It is an extension, but it's supported on like everything. So you can use that. I'll write a comment for it so we can do that in the future and see the gains rather than just doing it blindly. Right, so I don't really have a... Oh no, I have an occlusion section now, don't I? Oh yeah. So I'll just drop this in here as a utility function. And we can go over the code obviously because it's not going to work. We've got to edit it. So you pass in the occlusion texture. This should really just be a global thing, but maybe you could have... Could you have multiple of these? I don't know. Yeah, I don't think we'll have a different type of occlusion texture. We should probably just have that passed. It's all right. Just leave it in like that. So you pass in a bottom left, a bottom right in screen space. and an object depth. Now we have a function which gives us this. It's called the inside core shared. We've got a screen, bounds, and depth, and it gives us that sort of closest. What does it give us? The near depth. It does, doesn't it? Yes, I think if we take this, so this transforms the outer access line bounded box to screen space from local space. So you pass in a view to local, and then it does the rest and projects it down to the screen and all of that. So if we take that screen bounds and depth and we just pass it into this, we should have everything we want. Nice. So what is it? We've got a bottom left and a midpoint and a max point and a depth. So we see bottom left. Hang on a minute. They're floats. Right. So I guess we'll do like round downs and things and make them whereas the chord will just be alright. Okay, so I could precast them into integers. That would mean you want to round them down into integers, but then yeah, let's just do that. So we'll have like a bottom left, which would be the cast of floor bounds dot min point, right? And then the top left, top right, sorry, because bottom left is origin in this code base, and that'd be a sill, right? Round up, and then you get you max it out so it doesn't go outside the bounds of the screen, and then you get the width and height. Now the width and height, the top right should really be bounded in with the size of the screen, shouldn't it really? What is the dimensions of these? I guess here we'll call it the screen dims. Now realistically, we should be clamping both of these rather than just and screen dim, something like that. Oh. So we take that bottom left, go top right, so there are clamps there. You get proper width and heights. Now you calculate what is the largest dimension across the two. And if the largest dimension doesn't even make it a pixel, then we don't bother checking. We just say it's obviously occluded, right? You are going to round up though, so I think it's always going to be well, I guess if they're, if they're actually inside out, as in the top right is actually bottom left in a way, right? It's the minimax point and not minimax, it will cause this to be the case. Oh, no, it wouldn't. if it's less than. Yeah, or if they go outside of the screen, they'll be the same. Nice. Now what we're saying here is if the bottom left is, what are we doing here? Outside the bounds of the screen? Well, yeah, that would have been caught by this since we've done all those mins and maxes and things, right? And the same with this one. So that can go. Good. So this is calculating the MIP that we need to actually sample at to check the occlusion. So we take the most significant bit of the largest dimension. So this gets us the power of 2 in log 2. Right, so this gets us the power of 2 index, if you will, right, in log 2. So you do one shift left this number to get it to be that power of 2, right? So you take the MIPS counts, the number of MIPS for this texture. Yeah, this is where we might as well just make the occlusion texture a global thing, because if we're not passing this all in, it's just silly. So you should just pass in the bounds, and then just everything else is just global. And that would just be better. Yeah. All right, so we go to the internal shed. This is where the global thing is. In here, I guess we'll just stick in here. Oh, are you sampling a float? U32. Why is it sampling U32? I just bit casted it, didn't I? Alright. That's just something to do the old code base. Occlusion texture. Then I want to have some other occlusion-y bits. So what I would like to have is, what is the resolution? So not really we want to know the number of MIPS. We also would need to know so the occlusion texture is always of scene. Yeah, so I guess you want the occlusion dims. No, I did this one wrong. It should actually just be U32, obviously. So we'll set these from the CPU side. So graphics globals. So when we render the occlusion, we'll go ahead and set everything. Oh, already got it. We've already got it. Occlusion MIPS count. And then we also need the texture ID. Maybe I should make some of these like static and built, like just compile them into the shader code. But something for a few states to mess around with. Right, they're set there. So I did see that we already had this, this already declared it's right here, so that's good. So that's the occlusion stuff there in the global buffer. So it's just available to any shader. We just need to synchronize on the global buffer and the occlusion texture and stuff like that when we actually use it. The is occluded function. So we go to the shader code. Let's just figure out how to get back to that file. Here we go. So it is occluded. All right, so in here, we can now We don't have to pass in anything, right? We just get it all. So it's known as the scene dims. So we get the scene dims here. Scene dims. Cast graphics global scene dims, and that will be what we want. Yes. Cool. Now we write occlusion MIPS count. That's in the graphics globals as we wanted. So we calculate the MIP by getting the power of 2 rounded down based on the largest dimension. And then we clamp it with a MIPS count. And then we downscale, or we scale down the bottom left. So this will get it to the point where it'll be a 2x2. So scale bounds. So find MIP where bounds fits into a 2x2. Then this code gets that base coordinate. And it's doing another thing as well where it goes if it's out of bounds, because maybe yes, I think what we're gonna have to do, so you're gonna get that scene dims again. Oh, shift right. And shift right is, sorry, it's damn. Gotta be careful with these shift rights. So what we probably want to do is say, well, if it goes out of bounds of this MIP, because it can do that, you don't really have any information there. So you would then have to just render it, I think. That's the problem. But then it's doing some, is it doing some like clamping? I think we're gonna have to do a clamp. Yeah, this is a bit of a weird one. Yeah, this is why people use the sampler approach, because you can just get it to you by using a clamp sampler, and then it would do all the code for you basically, and it's quicker. So maybe we'll just go ahead and get that in there. Yeah, let's go ahead and do that. So if we just literally calculate the coordinate, all of this crap goes away, and it's just right. I think I kind of did the safeguarding here, but right. So there's that VK guide, the Vulkan guide. It has it on there, but under the GPU rendering section, it's got the compute-based culling. So this is kind of similar to that. So they use the max. There's a max filter or something like that. With depth. Special culling sampler. Yeah, so when they make the sampler, they use that extension. Wherever the hell it is. Yeah, the reduction min mode. Why the min? I take the minimum of those. Do you want to take the minimum? We're going to take the max. The minimum of the 2x2. Why do you want the minimum? So you've got a 2x2 and it's got a depth. The minimum will obviously be the closest. Do you want to take the closest? I don't know why you take the closest. Wouldn't that just lead to bugs? Still think you want to take the furthest. The min would lead to false positives, I think. Unless you're accounting for... Yeah, let's just do a max, because this would be safer. Cool, so we know the code. Right, so let's add this. It's a reduction mode. We'll look at that in the Vulkan code. So we go to GPU Vulkan. We'll find that there is a VK header here. We'll just look into that. I'm looking for the reduction extension. So they've got a min mode, they've got a max. Mode which we're going to use. And a weighted average. So I guess the weighted average is the default. Cool. So we can add this to our sampler. Is not present. Yeah, the default is weighted average. Perfect. So now we know. So we go to our sampler in gpu.h. So you can instantiate custom samplers as well. Min filter address mode, and I guess we can have a reduction now. I haven't really added much. For these, because I haven't really needed them. Reduction mode. Cool. So weighted average. Min, max. Neat. So we'll pass this in as another parameter into the sampler creation code. Now we'll find, it's pretty cool. Oh, of course you have to pass it in again. Be the internal header, right? Right, so reduction mode. Nice. And we're going to add that here as well, reduction mode, and then reduction mode. So we hop into, nick this again here, hop into the data structure. We'll then make sure we chuck that in there as well, right here. Cool, so now in the backend code, I think that's everything in the front end. So in the backend code, we've got to go ahead and do that. The dance that Vulkan wants you to do when you add extensions. Make another structure. Set the P next. Create info reduction. So you set the S type right to be the structure, so it knows. So it looks at the first. Was it 64-bit number or something like that, and sees what the type of the extension is that you passed in, and we want to actually do a max. And then in our case, P next will be null. We get rid of this. We don't need that. Nice. So we need to make sure that we, rather than just doing the max, sorry, that's me hard coding it, we need to declare these lookup tables to convert to a Vulkan one from our abstraction. So reduction modes. So the first one was weighted average, next one was min max. Nice. Reduction mode, min, reduction mode, max. Cool. So now we want to just put that in the header file. Throw an extern at the beginning because it's not a function. That's in the internal header. Just do it as more as a zoomed out bit of way of looking through these big files. And now every single time we call sampler initialize, we need to now pass in these reduction modes. Weighted average. That was long. There in it. Catch up. Oh, we'll see it complain in a bit. But even in the header file, right? Weird. So let's just see wherever else this is declared or this is used. Right, so okay. So now what we want to do is take this and put it into the graphics side of things. And we're going to make a special occlusion sampler. So inside the graphics internal shared, in that global structure, we're just going to place a super lovely occlusion sampler. HCC occlusion. HCC sampler. I think it's a read-only sampler, now that I remember it. Is there any, because it just keeps it consistent to what the other ones are. So that would be occlusion sampler. And then when we instantiate, so we've actually, so inside internal, just the CPU side now where we have those occlusion textures and stuff like that. GPU resource ID, occlusion sampler ID, like so. Now when we instantiate this, very nice, here we go. Occlusion sampler ID. Here we go, so it's a linear sample. Then how does it get reduced? Oh yeah, so yeah. So it'd be a clamp to edge, perfect. So when we go out of bounds, right clamps it. And then the weight we want is max. So the reduction rate is max, so just as a max up between the 4x4, sorry 2x2, with the 4 pixels. Then when we set up Global's occlusion texture, we can also do sampler, like so. Then finally inside the shaders.c, we can now change this code to use the sampler code. So if we get the texture available, so it's HCC, read only, wait, sample texture 2D of float. This is the occlusion texture. Then we get the sampler at the ready. Now, we don't need any of this because it's just going to clamp and it's going to be lovely. And all this code goes down to one line. Occlusion depth is just going to be equal to sample texture 2D float 32. We then pass in, I don't know why it does it looking like that, that's a bit weird. Occlusion texture. What is the sampler? So that would be occlusion sampler and the coordinate. So the problem is now this is actually the problem is this needs to be in like EV space. So to get into that, you just do division, right? So you take that bottom left. Now, you don't have to this scale down anymore. And then it means you just need to take that bottom left and divide it. This would have been clamped within the range. Well, yeah, it doesn't matter if it's been clamped anyway. But yeah, divide it. Hang on a minute. You're not going to get it at the right MIP level, are you? How's it going to select the right MIP? We can do some addition to the MIP level though, that's for sure, but yeah, so you can use the oh no, you can't just use sample because it's in a compute shader. If you use MIP level, then you can explicitly pass in a MIP level. That's right, that's the way you do it. So we want to say at a particular MIP. So we'll still, so we'll calculate the EV. EV is equal to the division of float casted bottom left with the float casted scene dims. So the resolution of the screen. That'll get you 0 to 1. Then you simply just fire that into there and the MIP level into there, and voila. These lines will go And that should be more optimized. Now you got the object depth, bounds.depth. If that is greater than the occlusion that we've got back, then that means that it is further back than the closest thing in the occlusion buffer. So it is therefore occluded. Cool. Right, so that's a nice little function we've got now. We've definitely minimized it a bit. Yeah, I don't know how I could make this a bit better. I think that's a bit nicer to read. So we just calculate these locals and then we do the sample. Cool, 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 cool. Right. So now we get to use this function. So I guess let's just run the game again. Oh, whoopsie. Forgot the word cast. So let's just make sure it all is going to work. GPU sample reduction mode, sampler. Right. Whoops. That's why it was complaining. And did I change that Vulkan thing? I didn't, did I? I knew something was up. I just made the array, I just didn't bother converting the enum over, did I? Cool. Right, things are still complaining. Oh, come on. I spelled reduction wrong. I put an E in there. What a melon. Well, at least I wrote that manually, you know? So yeah, we go to gpu.c. There's a couple of invocations in here. What did I spell wrong here? Oh, the sample there. And then in Vulkan, these have got the E on them, right? Cool. So that should compile and run. And now we can actually perform. Oh, for crying out loud, what is this? So you have to enable the feature. Right, sampler filter min max. So we've got to find where that is declared. What header is that in? The 1-2 features. Right. Here they are. Sampler. So he's got to enable that feature. Ought to be good enough. Switch from Helix to NeoVim. Yep. How do you cope with the key maps? Well, I remap all my key maps anyway. What's this complaint about? Yeah, I always remap my key maps on Vim anyway, because I use the Combat keyboard layout, and because it's a terminal-based interface, it uses key codes and not scan codes. Therefore, I have to remap everything because it's completely skewed or swizzled, might be the right terminology. So then when I went to Helix, I obviously had to remap all my keys anyway. But yeah, so they do the action then motion thing. Honestly, it's not a big deal. It's just it's just like learning. Whenever you change something in Vim, it's just learning it again, isn't it? It did take time, especially when I was only doing it part-time while streaming, right? I don't really stream full-time, so it was probably about 2.5 hours to 4 hours 3 times a week. It did take a few weeks to get the hang of it, and there's still a few little things that are a problem with it, like I can't find and replace too well. I need to get that keybind back because I overwrote it accidentally. But it's mostly good. I do much prefer the simplicity of Helix over NeoVim. But there's still some little things I hope they correct, but I do like it. Comes built in with like most things. I'm a bit sad that they lean too much on the language server protocol side of things, because when your thing is not language server protocol compatible, as in like your file is completely messed up, the super smart find and replace thing or any of the other intelligent stuff just don't work. So yeah, or if your if defs don't have the defines declared correctly, it will maybe not work as well. There's stuff like that. Yeah. Yeah. So image not null handle. Why is it null handle? What image was that? Oh, destroy image. Why did that happen? What have we done? I think we tried to destroy an image which is, oh, it's an invalid image object, right? It could be to do with the code that we changed when it's to do with the occlusion. Got an idea. So when we initialize the occlusion to, I put the stupid sampler in there. Right, this has to come directly after this create MIP views has to come directly after the texture initialized, because it allocates the IDs directly after the next ones. That's the problem. Cool. Right, we're back in business. So now what this is occluded function, it means that we can check if an object is completely occluded or not. So all these ones which are behind here, all these guys which are behind, if we set up like this, we should be able to see some of them get occluded with the occlusion texture. So let's just start it off with the ellipsoids, then we can move on to the model instances. So we find the graphics.c. Now we're looking for render models. So in render the models, got to be careful here. There's a tile bin ellipsoids. Oh, this is also worth the occlusion. Yeah, so the occlusion, excellent. So the beautiful thing about this is the occlusion buffer also calls this tile bin ellipsoids as well. So retile bins the. So the occlusion buffer is going to use the previous frame's occlusion buffer and check to see if the ellipsoids are occluded against that, and then render the ones which are not occluded against the previous frame's depth buffer. So that will already optimize that one. And then it will render a depth image into the occlusion buffer again, but a more up-to-date one. And then downsample that. And then we'll tile bin again with a correct occlusion buffer for this frame. And that will then hopefully save us some overall stuff that's going on. So we take the model instances and we emit the ellipsoids for those. So we find that shader. We're going to have to make sure that we read only on the occlusion texture because we're going to be interfacing with that now. It's just passing globally, so we don't have to pass it in via the push constants. It's globally accessible. So we find that in shaders.c. Now, this is where the fun begins. Maybe you don't do it here. But this just emits. It takes all the ellipses that we're going to render and then emits those. Data at a time, it copies them. Whereas this, the shader that does the tile binning, and it already gets that screen bounding box here. So I think we're better off putting it in here instead. Even though it kind of sucks that it is filling an array with data where it doesn't need to be. Maybe we should pre-calculate this. Yeah, because otherwise you're writing out memory you don't need to write out. It's just silly. So this is the next stage, the tile binning stage. So if we just wind back so it makes more sense. So we've got our model instances on the GPU. We run this, which takes the model instances and puts all the ellipsoids in an array for the ones that need to be rendered this frame. And then this does starts the tile binning process, and we call this shader here, which takes those ellipsoids that need to be rendered and then writes out these tile bin objects, and those then get binned into screen tile, duplicated and binned into screen tiles. So this is already doing that. Calculate screen bounding box from the ellipsoid for the ellipsoid. Well, why don't we just do that earlier, and then this shader can get more simple as well. Yeah, so perhaps this render ellipsoid here just needs to contain screen bounds, because that's what we want, right? Is R. Yeah. Why do we need the material index? What's that for? You just need the alpha in it? I think so. Where's the object? Where's the object ID? Where did it get that from? Oh crap. Oh, so these are actually, damn it. Right, these are actually going to be used in these are actually used by the renderer as well, the ray tracer. Hence why it's got the material index in there too. Okay. So maybe go over all of the ellipsoids. Ah. Right. So maybe this one needs to emit. Okay, what's the minimum amount of information that you need for this to go off? Well, this should just need to say, right, I've got an object index. So what you need, you got an ellipsoid that you need to be tile binned, shall we say. Maybe you need a separate array which kind of runs parallel to the ellipsoid, so you've just got the data that you need in here. So this will still stay here like this, but you need the other array. So render ellipsoids, and you probably want the bin ellipsoids. Ugh. So all this is doing is writing a bin objects thing. Is the bin objects? It's writing out it's squishing down the tile coordinate depth and an object. But we can't squish it at this point. And recalculating is kind of a bit. We could recalculate. Call the same function again. Yeah, I think it's just silly trying to emit all those objects. But if you recalculate this, it's a bit much, right? Should be better off maybe passing it around, so let's do that. So we're going to pass in a bin ellipsoid, I guess we'll call that. So this is the one that we need to bin. So this is just the number of, where's the render? Oh yeah, that's it. Cool. Maybe there's a better way to do it, but for now, this is the best we've come up with. So this is declared in the generator header file. So it's code gen. I don't think we can make. I kind of pack it and unpack it. Hey Sam Kalak. Welcome sir, how you doing? Welcome to the stream. Bin ellipsoid. I think we just put this in the shared internal, or internal shared. Always get that the wrong way around. Tile binning, no. PVH, anything. Alright. Stick it with these boys and girls. Graphics, bin ellipsoid. So I think we can just use the screen, bounds and depth. Let's call it bounds. And I think we pass in an object, or be an ellipsoid index as we know it. And we need a depth. No, the depth is inbound. Yeah. So that's 6 floats. Maybe it can get squished down at some point. I don't know. You see in the future if that makes any difference. Awesome. Right. So it's initialized. So in shaders, we now would like, so this atomically adds this sort of render ellipsoids count. Yeah. Right here. So when we go over our model instances, each thread group is a model instance, and then you get 32 threads to copy all the ellipsoids, but not all of the ellipsoids. You don't want to copy all of the ellipsoids into the, you want to do some sort of culling. So when you get the base copy index, so you got to go over and find out all the ones which you want to do. Probably use wave intrinsics here and do an add every time. The ones that pass. Yeah, I guess we'll do it that way. Right, so we want this sort of code here. Where's the render dims? Yeah, render dims as well, damn it. World from ellipsoid. Right, so we need to pre-calculate a view from model. View from model matrix, which would be the view from world. And world from model. Model instance, world from model. Nice. Now, we don't want to get the render ellipsoid. I want to get that. Near clip plane distance, let's keep that. Render dims. We need that to be passed in here now. It might not need to be passed into in the tiles anymore. I don't think so. We can can double check that. Yeah, we don't need it in the tile bin objects anymore. So let's remove that from there. All right, let's get back to the shader code. So let's try and organize this. So we can delete that line there. So this needs to happen later on in here, and so does this. Okay. Rightio. Right, so let's go over this again, because it's a bit, shader program is a bit different, right? So one thread group has 32 threads. Each thread group gets a model instance. It goes over, gets the model instance out, and gets the model that the instance is for, or of, shall we say. The local index is 0 to 31 inclusively. We pre-calculate the view from model by taking the view from world and the model instance world from model. Combine those boys and girls into a view from model. We could get the near clip plane distance here, which should probably just be a global anyway. And then we get the render dims casted into a float at the ready. Now we go over this for loop, steps at 32 because you have 32 threads, running in lockstep. Then you get your base, we get your source index that we're copying from the model ellipsoids, and if we go out of bounds, then they go inactive, right? Then you fetch the packed, well, it's not packed at the moment, but it will be packed ellipsoid from the model, that you get its model from ellipsoid matrix, and then you want to calculate the, so you got to do a matrix multiply. Maybe there's better ways to do this, and you're going to calculate the view from ellipsoid. So that'll take the view from model and combine it with the model from ellipsoid. Cool. So now with that, we can throw it into this super lovely function, which gets the outer axis line bounding box, screen bounding box roughly. It wastes space, especially when it's very close to the screen. It wastes a lot of space, but it's all right. Does the job. We pass in the render dims to the dims of the texture that we're rendering to. Ultimately, at the end of all this compute shader calculation stuff, we get the near clip plane distance, and then we get back the screen bounds and a depth. Either the camera is either the object is behind the camera or outside the screen bounds. Cool. So we return, do we return no? That means that so I want to say if it's not infinite, I guess you could say continue. That might just do it. So it'll make these lanes inactive that reach here. Sweet. Now we want to write out two things now. There is a render ellipsoid and there's a bin ellipsoid. So I guess we'll do an R. Now these are just because they're for two different things. The render ellipsoid is used by the ray tracer. The bin ellipsoid is used by the binner, which bins into screen tiles, right? So we need to put the bounds in there because the bounds are going to be useful for later. And we'll put in the ellipsoid index in which this is going to be inserted into. So that's what we'll send as the destination index. Now how do we get the destination index? Well, we need what's known as the, hang on a minute, let's do a bit of reshuffling. So we see if this is the first active lane within all of the active lanes which are going, so that, you know, it's up to 32. But if you've gone out of bounds, screen bounds, then it's continued. Now we get a new base insert index by atomically adding to this counter for the number of render ellipsoids that we got, and we're upping it by the number of ellipsoids that we're trying to add. So if we just take the wave active sum of 1, that'll give us the number of active lanes, which is trying to copy something. So this is the copy ellipsoids count. And then we get a new base index. That's only in the first thread, so what we have to do is take the min, because the rest of them have U32 max, and that will give us that'll copy it to the rest of the threads which are running in lockstep, which are active. Now we calculate a destination index for the ellipsoid. We got our bin ellipsoid here, and we've got our render ellipsoid. So we simply just copy them both in. Hang on a minute, did I just see something? It just needs to be some bounds. We'll keep it as a structure though. So it seems like we can just use the, yeah, it's a parallel array, so of course we don't need to pass this in. Silly me. Silly me. And voila. So afterwards we will use the bin ellipsoid, but just 2 seconds. The whole reason why we did this reshuffle is for the occlusion functions. We do is occluded, pass in the bounds. Now I shouldn't just call this R anymore, because R is a bit of a dumb name, to be honest. What does R mean? So if it is occluded, as in cannot be seen anymore, because it's definitely behind something, but it's not going to return false, or how should I say this? It tells you that it's definitely occluded, but it doesn't tell you that it's definitely not occluded. So if it can actually be behind something and not be seen, but just the way that the screen bounds is not a perfect calculation, it's a rough one. It will tell you if it's definitely occluded, but definitely not included is something it definitely won't do, if that makes any sense. So yeah, if it's occluded, we then continue also and don't bother doing the copy. Isn't that great? So we can actually extend this to work for the model instances too, which we will do in just a moment. Actually, let's do that right now. So if we take, so before we even do all of the ellipsoids, we should check the actual model. So I've got this view from model right here. All we have to do is take these functions here and paste them here. And just say something along the lines of view from model. So we get a bound. So we get a bounding box of the model. think that should work. Yep. No, it might not work. We need to encode the scale into the matrix. Because the ellipsoid already has that. Be careful, you see. No, that gives you a unit length of 1. Which means, then it'll be a 2. Yeah. No, the scale is encoded in there. Of course it is, right? I was just being dumb. So this will, you have a bounding box. So in the local space of the model will be like 1 by 1. The scale or something like that. And yeah. So you get the matrix, how you take that into view space basically. So it goes through the world into view. And get us a bounding box for these screen dimensions. Cool. If it's pointing the camera outside the screen, return. If it's occluded by other objects, then return also. Amazing. So, you determine the visibility of an object in the viewport. Yes, that is correct. So that's what this occlusion function does that we've just built, is that it ensures that it is, well, it's an optimization so we can just not render stuff that is definitely behind something. And if it could be visible, then we're going to try and we're going to try and render it. And yeah, you might try and render stuff which are actually invisible, but it's a rough guess, this occlusion stuff. Cool, so that's going to help us not emit less objects now. We should probably have a way to disable this and enable it, because then we can benchmark things at a press of a button. I would like to make a system overall which is going to help us enable and disable things like this very easily by bringing up a little sort of like search bar and type it in, or vaguely type it in, press a button, boom, you can toggle it. I'm currently in the process of trying to build that off stream, but I've been distracted the past few days since I've been going back to work and things. Right. So now this is the code that's changed. This is one that takes those, used to take the render ellipsoids and then turn that into these binning, ready to be binned. So now it's the bin ellipsoid. So we look. Just got to be careful here. So it's the bin objects buffer. This takes that screen bounds. We've just got to be careful here. We don't need any of this stuff anymore, which is great. So I'm not doing it multiple times. So it's only coming in here and trying to bin stuff onto the screen. So screen bounds R equals SV, bundle constants ellipsoid index dot bounds. Nice. So this R here, I guess we can just call it bounds. It's got a min point in screen space and a max point in screen space, but it's also got a depth. So we just get this out, I guess. Pass the far plane. Why isn't this in this code here, right? Why isn't it in this one? So would you say that's the near depth? It's past the far plane. Cool. So don't bother trying to render it. Right, so this is the one which takes those screen bounds, turns them into tile coordinates, and then emits them into another buffer, which is a specific bin for the amount of times that you want to copy it. So based on how, where's the calculate insert index? Oh yeah, sorry, based on the number of times you want to copy it. Because this might be very big and you've got to copy it to many different screen tiles. So it's got to, we've got specific shaders which are very good at copying 256 at a time, 32 at a time, 4 at a time, and stuff like that. That's all this is doing here. Perfect. Right, so that should be occlusion culling turned on. And maybe we should make a way to disable it. But let's just run it and see what happens. Right, wave active sum. I've got to put a U32 suffix on there. I could have done a wave prefix sum as well, rather than doing this min thing. I've just realized that. Want to see some magic? And I don't know why I keep doing this then. Oh no, you have to do the min thing. Oh, that means that, sorry, that source index is wrong. Hang on a minute. Okay, I'm glad I caught that. It's active prefix sum 1. So prefix sum will get you for every active thread within the, right? It will not return the sum of, so if all of your lanes are active, it will give you 0, 1, 2, 3, 4, 5, 6 across all of the lanes. What's the way of saying it? So if you're at lane 0, 1, 2, 3, and let's just say Y is active and is not active. This will get 0, let's get 1, let's get 2. So it's sort of like it adds them, but it adds them in the order that they're active in and retains the, it adds all the ones from the threads which come before you, basically, and you get the result. Yeah, that's the way of saying it. So it gives you a sum of all the threads that added one before you. There we go. Cool, so that's going to get us the proper destination index. Now let's just make sure I've not done that somewhere else where I've been completely dumb. Right, this is my splat code. Yeah, the prefix sum there. Right, it's good, we're in good places. Cool, let's go. It ain't much, but here's a Prime sub. Oh my days, thank you so much. It didn't pop up as the as a little thing. That's cool. Thank you so much. Appreciate it. Appreciate the thought. You also get access to the code base, by the way, if you didn't know that. If you connect it via, if you join the Discord, you'll be able to, there's a secret channel for all the supporters via Ko-Fi or via Twitch. Ko-Fi is, I get more returns on Ko-Fi if people want to send me more monies. Ko-Fi is the better option, but if you guys like Twitch, that's also cool. But yeah, if you join the Discord, I'll just link that. Code, that'll get you right there to the channel. And yeah, you'll be able to get access to the code, download on your Linux or Windows machine and have a play locally. Yeah, we're getting to a place where the renderer is going to be in a good condition, because I've basically built 5 or 6 different renderers for research and development purposes, just for a lot of learning. And this one is the final one where we're just taking all those learnings and building it, and then going back to the editors and actually trying to build ways to build content. So yeah, it's getting in a good place. I'm hoping by this month we're done with definitely by February, end of February, we're done with a lot of the rendering stuff and moving back onto like materials and things and finishing up the material editor. So there'll probably be some rendering stuff that goes on for the material editor, but in general we'll have like Bloom. I did a thing on it on the Discord. No, Mac is not supported at the moment. It's Linux or Windows, because I don't have a Mac, and I probably won't own a Mac for a good while. So yeah, it's just I like the old Mac. I used to have one, but it's just Apple is really weird, and you know, here's what I would say: I prefer Mac over Windows, but I prefer Linux over Mac. So yeah, if I had any choice between Windows and Mac, I would be on Mac. So yeah, we're going to be working on that occlusion buffer. We're sorting out the rendering so it's going to not have this weird Z fighting thing, and we'll try and render tons of model instances and see how it behaves. Check that performance with our built-in profiler thing. You can whip out with F4. And we'll want to probably look at the smaller ellipsoids and see how those behave. See if we want to fade them out or something like that. Just check like the highs and lows of things, and then render to HDR texture, because currently we do not. So therefore we have to tone map. And then do some bloom, because right now all of the emissive surfaces hey Voodoo. The emissive surfaces, what they do is they simply just increase the color, but they don't really sort of like look bright. So we need to do that bloom thing. So add bloom, and then we can go back to the material editor. I've thought of an idea how I want to do textures, and it's going to be interesting. So we'll probably be working on that sort of texture. We'll do a couple of materials, and the material editor is probably going to change a little to how we've written it already, but it's okay. For crying out loud, what's this? I need an R. World from model. Oh, we didn't make a world from model now. Damn it. Right, well, okay, I need the world from model. So, big pain in the butt. I've got these stupid matrix multipliers. You know, I'm just going to do the silly thing, and so this shader could be made faster by one of these matrix multipliers, I imagine. But yeah, so we need a... Hey, what? Hang on a minute. Hang on a minute. That's the line that was complaining, right? Yeah, okay. Then it's the world from ellipsoid. Have we got that? Okay. Right. Yeah, so there's all these extra matrix multipliers maybe that don't need to happen. Oh my days, what have I done? Shuffle must be vector found float. No. What am I shuffling? Wait, what emits a shuffle? I guess we can grep the sorry, it's cat the hang on, let's spivvy this. Build shader spivvy. Grep. No, put into less. Ah, I forgot what that was now. 6. Right, so the end of a function is occluded, right? The is occluded function. I thought we always never used it. Then it got included. So the shuffle happens when we do a .xy or something like that, innit? I think. So did I do like a dot syntax on it and I've not got? Or something dumb like that? Oh crap. Right, so we're using this function call here. And I've messed it up, haven't I? I've messed up the code gen. Alright, well at least we found a bug in the compiler. So it's doing a shuffle. So by default, it returns you a float. If you just got a float, it gives you a float fallback with like 001 or something like that. But I just sort of don't do that stuff. So I return the. Alright, let's get back into HCC and look at that. So it's in spivvy. Gen. So when we do that, so let's sample. See, I wonder why. I've done a load before. What does the load code work? I have num components 1. Pass me's already done it. You do the extract and it just extracts 0 out. Right. For crying out loud, I've got to get this moved over to Windows as well now. But yeah, so return type extract 0. So it extracts the .x parameter. Right, see where else I've bugged this up. Right, doesn't look like I have. Good. Right, so we generate another version of the HCC compiler, release build. We'll go and get build. Then I've got to go on Windows and do that as well, which we'll do off stream. Come again. Third party. Chuck it in there. Boom. Ooh. Now I'm this confident I'm going to close it all and run away. Recompile it. There we go. Cool. Now, how do we know if something's been occluded or not? Good question. We don't have any mechanism to know. So why don't we make a way to enable and disable the occlusion stuff? So we could, so you're still going to be doing the occlusion testing. We could say if it's enabled, just clear it to infinity and then return, or then and do a downsample maybe. So we could say do this, right? And then we say if it is enabled, actually do this. So I think we can get away with Boolean occlusion is enabled. So we'll then pop back to here. If gfx occlusion is enabled, we do the tile binning, do the ray tracing to get the depth, and then we downsample. Yes, so otherwise it would just be cleared. Well, hang on a minute. I did something a little bit silly. Else clear. You don't need to do downsample actually, because clear clears everything. Yeah, nice. And that should still. So now we should be able to see if we get a performance increase. We're not printing out the number of objects which have been. We could do like a stats thing where we count the number of objects which got occluded. How about MIPS count equals 0 or -1? Right, so that could be a way. Oh, okay. Right, so you pass that, interesting, so you pass that to the GPU. And the GPU then can... Yeah. Interesting, yes, that can maybe be... It is some invalid value, right? Then we could check the is occluded. And then that can just return true or something, maybe. It adds an extra if statement to shader code though, but then it will not run anything and that would be quicker. Yeah, I think I'll stick with this method because then it keeps the shader code same speed maybe. The same cost of looking up into the texture still. Yeah, I think so. But the approach you mentioned would actually fully disable it though. Yeah. Maybe that might be useful later on. But yeah, we need a way to count. Like, so if things got... We could count the number of occluded objects in some global and then view that number. But we could also just check performance. The problem is though, we haven't really got a good test scene. So imagine some of these are just going to be... So it's actually disabled by default, isn't it? So we toggle this thing, we're going to say render frame, or maybe so for now we can just say toggle based on operating system, virtual keyboard, key code has been pressed. And what key should we do? Could do like key modifiers as well. Yeah, let's just do the U key for now. Oh, that #20 thing. I don't know if it's enabled or disabled either. So we're just putting that into the terminal, occlusion. And if we see that, then we're looking for occlusion. So it'll be enabled by default. And then I turn it off. There we go. So the number of tile binning objects does not change. If we check the performance, the rendering performance does not change, but obviously the occlusion buffer stuff just shuts right down, doesn't do anything. The model still takes the same amount of time. So not seeing any difference there. Let's move back so we see more of the world. There is going to be glitches, so ignore that. Right, we saw some changes. All right, we're getting some things here. It's probably like the ones which are here. So see here, there's 5,000 sort entries. So there's 5,000 objects being binned into the screen right now. But if we disable it, wait a minute. Right, excuse me for a moment. Which one is which? This one's user interface, so ignore that. This is the correct number we should look at. That's a big one. The problem is it does it twice. So we type in for the UI as well. So anyway, this one is the occlusion. There's only doing occlusion buffer is only doing 196 for some reason. Okay. Okay, yeah. Right. So the occlusion buffer, when it does its tile binning, is trying to render it's trying to render 293 ellipsoids. And then after the occlusion buffer has been made, the model renderer is trying to render 196, right? And if we disable the occlusion buffer 1, we'll be left with 2 of them instead. You notice there's only that 293 here. So you see the times actually shrink down a little bit. Right, just a smudge. Because it doesn't actually make a big difference here. Because I guess they're sorted front to back, but in the future that'll make a big difference. We're not really seeing too many. No, for crying out loud. Oh, this is the profile that's run out of space. I just get it to use the static allocator. It's a bit silly at the moment. It's okay. Right, so we're seeing it take effect, which is good. So what we're seeing It's not obviously the best example, but we'll be improving it later on, doing proper tests. Yeah, they only really dropped 90 of them. Yeah, the thing where you see a difference is the number of objects that get... Oh, that's at half resolution. It bins 51,000 for the occlusion texture. Yes, when it's off, there's 209,000 which are being binned into the screen, which is a lot. But when you got it on, there's 201,000. But we had to bin 51,000 anyway and do the whole pass before. So yeah, this is obviously not beneficial running this occlusion pre-pass, but we've got to take this all into account when we are testing a proper scene and when I've sorted out this Z ordering bug, which I think is going to have a performance. We might have to... Yeah, might mess with performance. Trying to fix this bug. Might make it a bit worse, to be honest. But yeah, there's still things to play around with, like the size of these screen tiles, because we're binning... If we make the screen tiles smaller, the binning process could be quicker, because it doesn't have to copy crazy amounts of objects, it copies less objects. And but the small cost of the tile size being bigger, meaning that the ray trace will run a bit slower because it has to look over more objects. But when we have a more realistic set of ellipsoids to make up a model, we'll probably start seeing different numbers. And when we actually have a scene, it would be more realistic. Yeah, there's also things we could do. We could probably measure, like, is it worth running the occlusion buffer this frame, and then just don't run it, type of thing. But I don't think we'll ever encounter that when we have a proper running game. So maybe we don't need those things. We'll see. But yeah, so at least we got it in. It appears to be working. We probably would need, when we do our model instances and do render. Oh, here's a good check. Just invert the test and we can just see which ones actually got occluded. Gotta be careful though. So what are we saying here? Well, we're saying that's the whole model instance. Let's just say if it's not occluded, then we'll continue. So we're saying only render the ones which are occluded. So we can't see anything, which is a bit of a bugger. I've got to remember my controls, so let me get the original one back up. Right, I pressed escape, so it cancelled the movement. Alright, that was the problem. I know where to go to get the numbers. I just go right and go a bit back, but... Maybe we need to make a button. So you could run something where you say, well, if it got occluded, put that in a different array and then render those. And then you can always look at another texture. Or you could, you know, the stuff you can do there. Let's see how it takes to get to something where it is occluded. Yeah, it's pretty difficult to do it blind. So those went right, 1, 2, 3, 4. Move back a bit. That should... Why am I not seeing that? Did I delete the occlusion thing? Crap, what did I do? Oh, I removed the printf, didn't I? Okay, that's fine. Line 4 to... Yeah, but that's the... Oh, right, yeah, we could be including the whole models, isn't it? Do we want to... Let's comment that one out. Okay, wait a minute. So if the whole model got occluded, return. Yeah, but it's a bit silly. Yeah, let's just comment that line out. It's a good point though, because it's difficult. Because if you not that, you still want to see the ellipsoids which got 2, 3, 4. I can't see anything. No. Well, we probably need a way to... Yeah. What's a good way to debug this? So we had an option to say render occluded. Then you flip it or something. It's just weird. But then it will... Problem is these will get discarded as well. We could have just been seeing stuff which has literally just gone out the screen. So maybe this always fails. Always. So we could just do a GPU hprintf and just say, yes, it worked. And if we see that, then it actually worked. Load camera at the exact position you need. That is true. That's one way of doing it. Oh. Right, so we are see... There we go, we are getting them. Right, so I do have this sort of... I can just use this, that could help us. So we comment that out. Not that. Oh, you know what it is though? The problem is the occlusion buffer probably uses this as well. So... If you do that logic, then it would mean that the occlusion buffer that gets generated will be using the wrong ellipsoids, and then the test will pass or something. I don't know. I don't understand. But we could maybe take a peek into the occlusion buffer when it's saying yes, I'm not occluded or something like this. I'm not seeing anything show up now at all. Hang on a minute. I'm completely dumb. Yeah, maybe knotting it would be a bad idea. Maybe you've got to knot the... It's just bizarre. Yeah, so I think the occlusion texture that gets built is not going to be the one that you want. So you've got to somehow tell whether or not this is the first invocation within the allow transparency. That'll be it. That's how we tell. Right, so we knot it if we allow... BC. So allow transparency is on for... is on for the proper render, but when we do the occlusion render, it's obviously not... you don't have transparency in there. Oh. Right, we're seeing things pop up, kind of. Let's... Oh, that's a little weird, isn't it? So they're all occluded, apparently, because they've gone off the screen or something. Is that what it's doing? Right, okay, I guess we're seeing something. So, occlusion texture. Right, so this is where we're at. So we can flip between this. Wait, if I just... Here we go, we can control this. There we go. We've got sight. So how does that... That's what's the occlusion. Perfect, right. So yeah, these are occluded. Got there finally. That's interesting, right? So it's able to... Yeah, it's a little bit further back and it's occluding... I can't really tell. 95 objects, I guess, because they're the ones being rendered. Cool. So we're seeing something work. Let's have a bit of a play though. If I did that, what does it look like? So they're occluded. Cool. Right. As you can tell, they've got to be completely covered, so it is a bit random, but yeah. It appears to be working. So yeah, these are completely covered and guaranteed to be occluded. But yeah, so that's cool. Right, so I'm glad that's actually working. Just put that back to something sensible. Nice. So hopefully this pays off, this occlusion buffer thing, and actually helps out with the performance. We'll be able to tell when we've sorted out all the render bugs and got a renderer that we like. So next stream we're sorting out the bugs, fixing the overlapping and the Z fighting, and so I'll be thinking about ways to do that off stream. Hopefully, think of a good solution. I think I've already kind of got one, and then we'll test and fix a high number of model instances and probably bring in all those other silly model instance test things. We haven't really got an editor, so we're just doing silly stuff at the moment. We probably want to actually get transparency working as well. That's probably part of the Z fighting thing, because I've got some ideas around that. We should go over next stream. So next stream is Thursday, about 3 hours ago, so 7:30 p.m. GMT +1. And then there'll also be a stream on Sunday about 5 hours ago at 6 o'clock GMT +1. Right, let's find someone to raid. Awesome. I hope you guys all have a good Wednesday and Thursday. I'll hopefully see you all on Thursday. If not, not to worry. But yeah, fixing all the graphical issues and reworking a bit of the ray tracer. We've got 3 ray tracers. Remember, we've got the MSAA, the super sampled anti-aliasing, and the ray trace anti-aliasing. All varying different levels of quality and speed. They're all a bit of a trade-off. Ah, Raymarch, my friend. Cool. Alright, I'll see you all very soon, guys. Thank you all for coming by, and yeah, catch you later.